Good day! Welcome sa next lesson natin, which is combinations. Now, this was meant to be included dun sa first video natin on permutations and combinations, but it got too long, so I decided to cut it and just attach this introduction dun sa rest of the video. So baka weird yung jump. Anyway, let's proceed. Now, let's introduce combinations. So, permutations, importante yung order. Combination is a selection of objects where the order is not important. For example, how many ways can 3 reading assignments be assigned from 5 available book choices? Pag binigyan naman kayo ng reading assignments, it's really up to you kung ano yung uunahin nyo. So, walang order. Walang first reading assignment, second reading assignment, third reading assignment. Parang, basta, ito yung tatlo, bahala kayong basahin. Basta basahin nyo lahat. So, how many ways can 3 reading assignments be assigned from 5 available book choices? So, this could be one set ng reading assignment, one from the red book, yellow book, and green book. Or palitan natin yung green book with blue book. Or palitan natin yung blue book with the purple book. Yan na yung 5 books natin. Red, yellow, green, blue, and purple. Pwede rin nating palitan yung yellow, gawin natin green. So, green and blue. And so on. Take a look at all the possible combinations for the 5 books. And we can see that we have a total of 10 available sets ng tatlong different reading assignments. Let's check. Out of the 10 groups, 6 sa kanila may reds. 1, 2, 3, 4, 5, 6. So dapat pantay-pantay na 6 din yung meron sa iba. So we have 6 na yellow, 1, 2, 3, 4, 5, 6. 6 na green, 1, 2, 3, 4, 5, 6. 6 na blue, 1, 2, 3, 4, 5, 6. And 6 na purple. So 1, 2, 3, 4, 5, 6. We have 5 available book choices and nag-a-appear sila dun sa possibilities na pantay-pantay na tig-6. So alam natin na ito na lahat yun na pwede nating arrangements na magawa. If order is important, then this would be 5 times 4 times 3 or 5 factorial over 2 factorial ways. And if order is important, ilang ways natin pwedeng arrange ang tatlong books? 3 factorial ways. So ito yung tatanggalin nating arrangements from the 5 factorial over 2 factorial ways. Kaya natin siya i-divide by 3 factorial. The total number of groupings na magagawa natin from 5 books and each group has 3 reading assignments. So, the 5 factorial over 2 factorial over 3 factorial. So, yung 5 factorial over 2 factorial, that's the number of ways na makakuha tayo ng 3 books out of 5 kung may order. So, 5 times 4 times 3. And yung divide by 3 factorial, yan yung i-disregard natin yung importance ng order dun sa tatlong books na pinili natin. Ang basa natin dito ay yung combination of n objects taken R at a time. Or sometimes, n choose R or n taken R. Those are all valid ways na basahin itong small n, capital C, small r. Another notation for n choose R or n taken R, which I actually prefer, is itong notation na to. Parang may parenthesis, then may n sa taas, r sa baba, pero hindi siya fraction. Walang fraction bar. Pareho lang yan. And this is equal to n factorial over r factorial times n minus r quantity factorial. I-break down natin itong formula na to. Yung n factorial divided by the quantity n minus r factorial, so itong part na to, yan yung permutation. Na meron akong n objects, tapos mag-a-arrange ako ng r objects from that n objects. Then, itong r factorial na dinidivide natin dito, yan yung pagtanggal nung importance nung ordering dun sa n objects na pinepermute ko yung r objects sa kanya. So, by removing yung importance nung order, nagiging combination siya. So, again, this part is the permutation formula. If you divide it by r factorial, you remove the importance of the order or remove the number of ways to arrange r objects, nagiging combination siya. Let's take a look at some examples. Sa PCSO Lotto 642, madami kasi yung types ng Lotto, may hanggang 50 yata. So 642 muna, ito yung pinaka-konting choices. At ito din yung pinakamaliit yung prizes. You can choose 6 numbers from 1 to 42 in any order. How many total combinations are possible? Let's pause this. Maybe get a calculator and see if you can compute for the number of combinations of 6 numbers from 42 choices, and let's compare our answers. So this is just a matter of plugging in yung values natin sa formula. Pwede natin siyang isulat na parenthesis 42 sa taas, 6 sa baba. And it's just a direct application ng formula. This is 42 factorial over 6 factorial divided by 42 minus 6 or 36 factorial. This will give us, madami pa rin, 5,245,786 ways or possible combinations of 6 numbers from 1 to 42. So kung gusto mong siguradong manalo sa Lotto na to, then you'll have to buy all possible combinations and you'll have to buy 5,245,786 combinations. Second example, how many ways can you make a committee na may 3 beryllium students at 4 na strontium students? So a committee of 7. And ang eligible lang ay 10 beryllium students at 12 strontium students. So hindi lahat pwede. 10 lang from Be, 12 from strontium. So let's pause this and let's see if magiging pareho tayo ng sagot. Start by taking the number of ways we can get 3 students from beryllium out of 10 possible students. That is 10 choosing 3. And this is equal to 10 factorial over 3 factorial times 10 minus 3 or 7 factorial. So this gives us 120 ways to choose 3 beryllium students out of 10. Ang bibilangin naman natin ay how many groups of 4 strontium students yung pwedeng kunin out of 12. So this is 12 choosing 4 or 12 taken 4. Our formula is 12 factorial over 4 factorial times 8 factorial. This will give us 495 ways to choose 4 strontium students out of 12. So meron tayong 120 ways para kumuha ng beryllium students and 495 ways para kumuha ng strontium students. To get the total number of ways na pwede natin silang i-combine, this would be 120 times 495. This will give us 59,400 ways to form the committee. Lastly, this is not an example, but more of a theorem. We want to show that n plus 1 choosing r or n plus 1 taken r, this is equal to n taken r minus 1 plus n taken r. We will show this identity in 2 ways. Yung una, gamitan lang natin siyang straightforward na computation. Start with n plus 1 choosing r. We want to show that this is equal to n choosing r minus 1 plus n choosing r. Pero ano ba si n choosing r minus 1? Ano ba si n choosing r? Expanding the combinations, si n choosing r minus 1, this is equal to n factorial over r minus 1 factorial. Tapos ito, di ba dapat n minus r minus 1? So we'll just distribute the negative sign para maging n minus r plus 1, quantity factorial. So this is the first term, plus n factorial all over r factorial, n minus r factorial para dito. Ang gusto nating gawin ay ma-add sila. So we want their denominators to be the same. We'll do that by starting sa first term, multiply tayo ng r over r. So numerator natin, r times n factorial, yung denominator, r times r minus 1 factorial, then ito pa rin, n minus r plus 1, quantity factorial. Yung second term natin, ang i-multiply naman natin ay n minus r plus 1 sa numerator at n minus r plus 1 sa denominator. So no change for the numerator, but we have r minus 1 factorial times r. So these two factors, kukompress na natin siya to r factorial. No change tayo sa n minus r plus 1 factorial. Ito naman tayo titingin. No change sa numerator, but sa denominator, we make the observation that n minus r factorial, yung next number na mas malaki sa kanya ay n minus r plus 1. So these two factors, pwede natin i-compress into n minus r plus 1 factorial. So now, pareho na yung denominators natin. Pwede na natin i-add yung numerators. So yung first term, pinagpalit ko lang yung position ni r tsaka n factorial. For the second term, as is siya. What I want us to notice is that common factor, si n factorial sa taas. So let's take it outside. Yung magiging value sa loob ng parenthesis ay magiging r plus n minus r plus 1. Pero hinighlight ko yung r. Kasi yung r tsaka yung minus r, they will cancel each other out. So this will give us n factorial times n plus 1 na lang sa taas. And what is n factorial times n plus 1? That will be n plus 1 factorial. And yung other factor natin sa denominator, i-change ko lang yung position ng negative r tsaka yung 1 para maging 1 minus r. So it will be n plus 1 minus r. Kasi n plus 1 yung numerator. So ano ngayon ito? This is exactly n plus 1 choosing r. So nakita natin na equal yung right-hand side sa left-hand side. Now, this type of proving, medyo tedious siya, tas puro letters na nakikita nyo, and baka hindi nyo nasundan fully, okay lang yun. We have another way of proving combinations. It's called the combinatorial proof. So, ko-provide tayo ng scenario. And hopefully, mo-connect natin yung logic ng scenario na yun. We'll do that by asking, kung ano ba ibig sabihin ng n plus 1 choosing r. So, let's say I have n small animals, tas meron akong isang malaking animal na out of the group. So, hinhighlight ko si Palawan flycatcher. Huwag na nating bilangin kung ilan yung maliit. Basta n sila. So, may isang sumasali na malaki. So, we have n small animals and 1 Palawan flycatcher. What does n plus 1 choosing r mean? It means the number of groups of our animals na pwede nating kunin from this set. It's essentially answering the question, how many groups of our animals can we take from this large set of n small animals and 1 Palawan flycatcher? Intindihin naman natin kung ano sinasabi sa atin nung n choosing r minus 1 tsaka si n choosing r. So dahil mas maliit si n kay n plus 1, we could take that as the group of small animals na hindi nakasali si Palawan flycatcher. And si n choosing r minus 1, this is asking us ilang groups of r minus 1 animals yung pwede nating mabuo from n small animals. This is the number of groups of r minus 1 animals from this set. So again, ito groups of r, ito groups of r minus 1. Ano naman si n choosing r? It's the same group, but we're now looking at the groups of r animals from this set. So parang pareho dito na may r animals. Ang contention natin, ang gusto nating ipakita ay pareho yung number of groups from this set ng R animals at idadagdag natin dun sa number of groups of R minus 1 animals. Pareho lang siya dito. Bakit? Dito sa group na to, na meron akong n plus 1 kasama si flycatcher na animals, tas meron akong groups of R, yung groups na yan na tig-R, andyan yung mga groups na kasama si Palawan flycatcher at yung groups na hindi kasama si Palawan flycatcher. So now, this group na may tig-R animals, wala naman si Palawan flycatcher dun sa choices. Yung number of groups na to, pareho yan sa number of groups dito na wala si Palawan flycatcher. Kasi kung ilang groups dito na magagawa mo out of all animals including Palawan flycatcher, pero wala si Palawan flycatcher sa group, di pareho lang siya dapat dun sa magagawa mong groups of our animals from n animals na wala naman talaga si Palawan flycatcher in the first place. So this is the number of groups from the left group na hindi kasali si Palawan flycatcher. Yung group na to, ito yung groups of R-1 na magagawa mo from this set. Imagine, mayroon akong groups of R-1 animals. Sa bawat group na yun, isasali ko na si Palawan flycatcher. Parang na-late lang siya, wala siya selection. Then kumuha ko ng groups of R-1, i-join ko na doon si Palawan flycatcher. So that covers all the groups from the left group na kasama si Palawan flycatcher. It's like taking all the groups here na nandun si Palawan flycatcher, then papalayasin mo siya. You'll have the same number of groups here. So logically, yung total number of groups na wala si Palawan flycatcher at yung total number of groups na kasali si Palawan flycatcher, that is equal to the total number of groups na magagawa mo dun sa set na andun naman si Palawan flycatcher in the first place. And now, we have two proofs that show that n plus 1 choosing r pareho sa n choosing r minus 1 plus n choosing r. Why is this important? In our next lesson, gagamitin natin tong identity na to para i-establish yung Pascal's triangle. If you will recall from grade 7, how do you get yung next level ng Pascal's triangle? Di ba mag-add ka ng dalawang numbers from the top. So we will relate this identity to Pascal's triangle in our next lesson. So goodbye and thank you muna for now, and I'll see you sa next lesson natin.